Welcome back to the deep dive. So we've got this stack of sources on professional video hardware, and today we're really zeroing in on one specific piece of gear, the Datavideo PTC-285W. It's a 4K auto-tracking PTZ camera that promises, these high-end results without a whole production crew.
Right.
And our mission today is to get way beyond just the 4K label. We want to understand the intelligent stuff, the systems that make this camera actually useful for, say, a solo operator in a school or a church, automation that doesn't look like a robot did it. Okay, let's unpack this.
It's a really flexible tool. I mean, to start with the basics, the image itself comes from a 1/2.5-inch CMOS sensor. It's got 8.51 megapixels.
Okay, solid specs.
Yeah, but what's really fascinating is the simultaneous output. You can get full UHD 4K, 60 frames per second, over both HDMI 2.0 and IP.
At the same time.
At the same time.
Yeah.
Plus, it's also kicking out a 1080p 60 signal over 3G-SDI, so it plugs into basically any system, old or new, without needing extra converter boxes.
That's a great baseline. But the thing that really jumped out at me for the end user is that auto-tracking feature. Because if you're a professor giving a lecture, you need the camera on you. But what happens when, a student walks in front of the lens?
That's the exact problem this AI algorithm is built to solve. Most basic tracking systems just lock onto any motion, which is super unreliable.
Right.
The PTC-285W, it uses this AI to let you pick one specific person to follow. It's smart enough to ignore all the other stuff, people crossing by, things moving in the background. It just stays locked on the presenter.
So it solves that interference issue. But what about the movement itself? So many of these PTZ systems look, jerky and robotic when they move.
And that's the other half of the equation. It's a feature called Smart PTZ Speed Adaptation, and it's run by something called a PID algorithm.
A PID algorithm. So what is that? Like an advanced cruise control for the camera?
That is a perfect analogy. Older systems are purely reactive. They see the person moved, and then they chase after them. That's where you get that jerky stop-start look.
I see.
The PID algorithm is predictive. It's constantly watching how fast the person is moving, and it calculates the right pan, tilt, and zoom speeds before the movement is even finished. So it's smooth. It looks like a human is operating it.
That smooth motion is absolutely essential, especially with 4K video. And the physical range on this thing is, it's massive. A 300-degree pan, 145-degree tilt.
And a wide 80-degree field of view to start. Paired with 12x optical zoom, it can cover a huge auditorium from just one spot.
Which is great.
And if we connect this to the bigger picture, once you have it mounted, how do you power and control it easily? That's where power over Ethernet, or PoE, comes in.
So for anyone who's struggled running cables, that's a huge deal. You just need one network cable for everything.
Exactly. One single Cat6 cable. That's your power, that's your control signals, all of it. It just massively simplifies the install.
That's incredible.
And on the Pro side, it's ready to stream directly. It uses RTSP and RTMPS protocols, so you can send video straight to two different platforms like YouTube and another CDN right from the camera.
And I noticed a little detail I loved, the green and red tally lights.
Yes. It's a small thing, but so important in a live environment. The person on camera has to know if they're about to be live or if they are live.
It's that professional touch.
It is, and it has all the standard control protocols, Pelco-D, Visca-D, VIP. It'll drop into pretty much any existing system. Plus, you can save 255 presets.
So you can just snap to the whiteboard, to the podium, wherever you need to be.
Instantly.
So really, the core appeal here is clear. It's that professional, high-res image combined with automation that is finally smart enough for a real, unscripted environment.
Right. It feels human. But, this raises an important question for me. The sources mentioned that it has advanced 3D noise reduction, and it only needs 0.5 lux of light to work. That is incredibly dark.
Wow. Okay.
So my question is, when you put that kind of amazing low-light performance together with this smart automation, how might that change the actual requirements for lighting a space, like a remote classroom or a house of worship?
You mean you might not need all those big hot lights anymore?
Exactly. You could create a much more natural ambient environment instead of blinding the presenter.
That's a truly fascinating thought, that the camera tech itself could change the design of the entire room. Something to think about. Thanks for diving into this with us. We hope you enjoyed this deep dive, and we look forward to the next one.